Hello everyone and welcome to Infinity Learn by Sri Chaitanya. I'm Ravindram and today I'm going to be discussing with you the physics portion of the LTC MPL weekend test 14. Okay, so let's go with the first question. So the first question says that a current of 4.8 ampere is flowing in a conductor. Okay, current has been given. The number of electrons passing per second through the conductor will be. Okay, fine. See, I is equals to delta Q upon delta T, right? And what is delta Q? Delta Q is number of electrons into charge of a single electron upon delta T. So what they are asking is N by delta T, that is what number of electrons per unit time into charge of electron. So N upon delta T will be I upon charge of electron. What is current? 4.8. What is charge of electron? 1.6 into 10 to the power minus 19 coulombs. Okay. So here you can solve and get the first option right. Second one is variation of current and voltage in a conductor has been given. The resistance of the conductor is very simple. V equals to I into R, right? So V upon I is equals to R, or I should say delta V upon delta I is equals to R. That means in this diagram, the slope of the straight line will give you the resistance, which is what? 1 ohms. Okay, because this perpendicular is 4 and this base is also 4 units. So 4 pi 4 is 1. Negligibly small current is passed through a wire of length. Length is given, area of cross section is given, resistance of the wire is given, and they want you resistivity. It's a simple formula based question. R is equals to rho L upon A. So simply you can say R into A upon L. But make sure that the values are put in the proper units, right? Now, a current of 10 amperes is maintained in a conductor of cross section. So cross section is given, current is given, electron density is given. That means number of electrons per unit volume is given. What is the drift velocity? Simple, we have one formula here, NEAVD, right? I is the current, N is the electron density, number of electrons per unit volume, E is the electronic charge, A is the area of the cross or the area of cross section of the wire. So drift speed will be I upon NEA. What is I? I is current, N is also given, I is given, N is given, electronic charge we already know, and area of cross section is also given. So all these 4 values are already available in the question. You just have to put them in the proper sequence and then you will get your answer. That is the drift velocity of free electrons. I hope you can do this. I don't need to solve it here, right? Fifth question. Now one important stuff I want to explain you that whenever a wire is not having a uniform cross section, is changing, then we say that the amount of charge per unit time which is at the entry or at any point, right? Let's say I delta q by delta t at entry and delta q by delta t at exit. That means I1 must be equal to I2. Current remains same because charge do not accumulate in any portion of the wire. So charge conservation principle will be valid here. So we will say NEA1 VD1 is equals to NEA2 VD2. So N and E, they are also properties. They will get cancelled out. So ultimately you will say that area A1 into drift speed at first cross section must be equal to area A2 and drift speed at another cross section or at exit, right? So this is valid. Current is constant. So when they talk about what will happen to current will remain constant. That is third option, right? Now drift velocity of electron. Now clearly we can see that area into drift speed is constant, which means that drift speed is inversely proportional to area, and on moving from point A to point B, anybody can say that the area is increasing. So clearly we can say that drift speed is reducing or decreasing, right? So which option is correct? Second option is correct. Now what about electric field? See students, we know one thing for sure, that drift speed is equals to E tau by M into electric field. That means drift speed is directly proportional to electric field. Please remember this fact. This is important, right? Because E is electronic charge, tau is relaxation time, property of the conductor, M is the mass of the charge, that is also a universal constant, right? Mass of electron. So what we will say that drift speed is directly proportional to electric field. Now in this case, if drift speed is reducing, obviously area obviously electric field will also be reducing. So second option is correct for electric field as well. Now potential drop per unit length. This is little bit interesting. See, potential drop per unit length. Okay. Now what is potential drop? See, we say that I into R is equals to V. Now I into rho L by A is equals to V. So from here we can say that I into rho upon area is equals to V by L. Now what is V by L? Potential drop per unit length. Now, rho is the resistivity which is constant, I is constant. So, I into rho upon area is equals to V by L. So, from here we can say that I and rho are constant. So, V by L is inversely proportional to area. So, if area increases, then definitely this ratio will reduce. So, again for this also, second option is correct. So, so it is like that 3, 2, 2, 2, right? 3, 2, 2, 2. So which is correct? Second option is correct. Can you see this? Okay. So this was a very nice question. Okay. Now let's move on to the sixth question. They are saying a cell dissipates. Okay. So there's a cell like this. How does a cell looks like? Like this. This is EMF. This is internal resistance small r, and this is R1 connected separately. Then we have R2 connected separately. Okay, so we can say that EMF is equals to I1. Okay, what they want is cell dissipates the same power across each of the two resistances. Okay, same power. So let's discuss what is the power dissipated in the first case. It will be I1 square into R1, and it will be I2 square into R2, right? So I1 is how much? E upon small r plus capital R1 whole square into R1 is equals to E upon small r plus capital R2 whole square into R2. Got it? Now, when you solve this thing, you will say that R1 upon R2 under root is equals to small r plus R1 upon small r plus R2. Now, if you closely look, if you take the fourth option instead of small r, because on solving, obviously, definitely you will get the answer right on solving. But if you don't want to solve, you can just see that this is not possible with, if you put the value small r as R1 plus R2, you cannot get this answer, right? LHS and RHS will definitely not be equal. First and second options are gone. Third option, definitely you can see you are not getting the answer. So obviously fourth, you just put the value here and you will see that the answer is correct. Okay, RHS is equal to LHS. Got it? This is how we will go for the fourth option. Now let's discuss the seventh question. They are saying, just now we have discussed that if the cross section is non-uniform, then current is constant. Drift speed changes. Okay, electric field changes, drift speed changes. Got it? Eighth, what they are saying is a current I flows through a wire of radius r, mean drift velocity is v. The same current will flow through a wire of radius r by 2 made of same material, then the mean drift velocity of the electrons is. See, I is equals to NEAVD, right? I is same. Okay, I is same here. So if radius is halved, that means see, area is pi r square. So area will become 1/4 if radius is halved, right? So if area is becoming 1/4, so we know that AVD is constant in non-uniform cross section. So we can say that if area becomes 1/4, velocity becomes 4 times. Got it? If area becomes 1/4, automatically this becomes 4D. Clear? Now, a filament of the bulb. This is an interesting question. Okay. See, this information tells us about the resistance of the bulb. V is 100 volts and power is 500 watts. Let's say the resistance of the bulb is R naught. We need to figure out. We will say V square upon R naught is equals to power, right? So let's figure out the resistance of the bulb. That will be V square by P. Now what is V? 100 into 100 upon 500. So what will be the answer? 20 ohms. What is the answer? 20 ohms. Now what they are saying is it works perfectly. Okay, very good. So we have two resistances. One is R naught, another one is R, right? We don't know its value, and it is connected across a battery of 230 volts. Now listen to me very carefully. If it is 230 volts, but this bulb is working perfectly, that means the drop here is 100 volts only. So what is the drop here? Automatically 130 volts. Okay, clear? So what they want is this. Okay. So we know that the drop here is 30. So we can find out the current in this resistance. See, I into R naught is equals to 100. R naught is what? 20. So I into 20 is 100. So what is the current in the circuit? 5 ohms. Sorry, 5 ampere. What is the current in the circuit? 5 ampere. So what they want is the value of R. So we will say I into R is 130. So R will be what? 130 upon 5. How much will that be? 26 ohms. Is it clear? Okay. So next, let's move on to the next question. Okay. So this is a very easy question. Here they have given us a wire of resistance 4 ohms. What is the resistance of the wire? 4 ohms is stretched to twice its original length. We all know that. See, resistance is rho L by A. We can also write it like this: rho L square by area into length, which is volume. So rho upon volume into L square. Now resistivity on stretching, resistivity won't change and volume also will not change. So resistance is directly proportional to L square if you stretch a wire. So if you stretch it to 2 times, right? So if you stretch it to 2 times, so obviously resistance will become 4 times. Okay, so R dash will be 4R. So 4 into 4, answer is what? 16 ohms. Got it? Now question number 11. This is an interesting one. There are 45 number of cells. 45 number of cells we have. Okay, with internal resistance. So each cell is somewhat like this. Okay, this is EMF. This is a small r. Okay, small r is 0.5 ohm. Okay, now they want that like this. How many cells should be connected in series and how many rows like these should be connected so that the power output at the final output resistance R is maximum. Do you understand? So what they are saying is that we have n cells and how many rows we have? M rows. So overall how many internal resistances we have or cells we have? So n into m is equals to 45, right? This is the total number one. Number two, next thing that I want to talk about is this. When is the power maximum? You will say that the power is maximum when overall internal resistance is equals to external resistance. Now how we will get this? Come on. See, it's very easy. For every row, what is the equivalent resistance for a single row? It is n times a small r. And how many rows are there? M rows. So divided by n. This is your equivalent internal resistance, right? Is equals to capital R. So n by m into 0.5 is equals to 2.5. So I can say that n upon m is equals to 5 upon 1. Now using the first and third equation on solving, see n is equals to 5m, you put there, you will get the answer, right? So m will come out to be 3 and n will come out to be 3. That means there will be 3 rows and every row will be containing 15 cells. Okay, got it? Now 4 wires made of same material have different lengths and radii. The wire with more resistance in the following cases. See, what is resistance? Resistance is rho L by A. Okay. So you just have to check for which of the following L by A ratio is maximum. Right? That's all. In this is all you have to do and find the answer. 13. If the resistance of the circuit having 12 volt source is increased by 4 ohms. Okay. So there is a voltage source of 12 volts and there is some resistance, let's say capital R, and there was initially some current I. So initially we can say I into R is 12, number 1. Second, they are saying if the resistance increases by 4, the current drops by 0.5. But still the potential drop will remain what? 12 only, because they are connected across the same battery. Because they are connected across the same battery, so the drop will remain same. Now if you solve it properly, see what you're gonna get is this. You will find a quadratic actually. You will say I is nothing but 12 upon R minus 1 by 2 into R plus 4 is equals to 12. Now this is your main equation. Now if you solve it, you will get a quadratic. First of all, if you simplify it, you will get a quadratic, and then when you finally solve it, you will get R equals to 8 ohms. Got it? So after solving, you will get this answer. This is how it will work. Now we know that dV by di, that is slope of this graph, is going to give you the value of resistance. So slope is negative in this particular portion. That is why here the resistance will be negative. Okay. See, IV graph. See, V equals to IR. So delta I upon delta V is equals to 1 by R. Right? And resistance depends directly on temperature. So this is the slope here. So greater the slope, lesser the resistance. That means R1 is less than R2. So definitely T1 is less than T2 because resistance is directly proportional to temperature. Got it? Third option is correct. Fourth, we know that in a conductor, on increasing the temperature, resistance increases because the relaxation time decreases, the collision frequency increases, the electrons start colliding more vigorously and they have lesser amount of time between two successive collisions because tau reduces. That is the reason for increment in the resistance in conductors. Okay. Now this is an interesting question. Here we will say that at 0 degrees Celsius or 273 Kelvin, resistance, let's say it is R0. Okay, so R1 is what? 1 ohms. Okay, so R1 is R0 into 1 plus alpha delta T will be how much? 300 Kelvin. 300 minus 273. Got it. Minus 273. And R2 will be R0 into 1 plus alpha into T minus 273. Now you take the ratio. R1 is what? 1. R2 is what? 2. It will be 1 plus alpha into 27 upon 1 plus alpha into T minus 273. Now once you solve it, you will get this answer. Okay? Clear? Any doubt? Now 18. Okay. See, copper is a conductor. So when you increase the temperature, whenever you increase temperature, then once again, that is okay. Whenever you increase temperature, resistance increases for a conductor. Resistance increases for a conductor, but resistance reduces for a semiconductor. Okay, so based on this logic, since germanium is a semiconductor, so if you cool it down, so if you reduce the temperature, the resistance of the copper strip will decrease and that of germanium will increase. That means what we can do is, instead of increasing, they're decreasing the temperature, no? They're reducing the temperature. Fantastic. So if you reduce the temperature, so resistance in conductor reduces, but in semiconductor increases. Got it? So copper is a conductor. On reducing temperature, its resistance decreases. Germanium is a semiconductor. Its resistance increases. Got it? Now, the fundamental frequency of an open organ pipe increases as the temperature is increased. See, frequency is equals to NV by 2L, or it is directly proportional to V, or it is directly proportional to root over T by mu. Okay? As the temperature increases, okay. Acha, they are talking about organ pipe. Sorry, they are talking about organ pipe. So it will be gamma RT by M naught. Okay. So if you increase the temperature, okay, the velocity increases. First, fine. First option is right. Second, the fundamental frequency of vibration of 1 meter long string. 1 meter long string is 256 hertz. Okay. See what is fundamental? V by 2L. Right. So F naught is inversely proportional to length. So if you reduce L to L by 4, then frequency. So if you reduce length, in frequency increases. So if you say L is L by 4 now, so frequency will be 4F naught. So do just 256 into 4 is equals to third option, 1024. Got it? Now 21. These are some easy questions. An organ pipe open at both ends in nth harmonic is in resonance with a source of 100 hertz. So it is 100 hertz. It is open at both ends. So if it is open at both ends, we know the formula. It is NV by 2L, right? So 1000 is equals to N by 2. L is how much? 16.6 centimeter. Do you know 16.6 centimeter is nothing but 50 by 3 centimeter, or you can say 50 by 300 meter, or you should say 1 by 6 meter. So it is 1 by 6 into V is how much? 332, right? So you will say N is equals to 2000 upon 6 into 332. Ones are ones. So answer is 1. Exactly 1. Okay. Now stretched string of length 1 meter fixed at both ends. Okay, so there's a string which is fixed at both ends and it is plugged at a distance of 25 centimeters. So if it is plugged, that means here antinode will form. So it will be somewhat like this, right? That means see, lambda by 4 will be equals to 25 centimeter. So lambda will be equal to 50 centimeter. Okay. Now what they want is, so speed will be how much? T by mu under root. So it is 5 into 10 to the power minus 4 upon 20 upon 1. Sorry. Tension is 20, length, mass is 5 into 10 to the power minus 4. Okay. So 20 upon 5 into 10 to the power minus 4 upon 1 under root will be 200. Okay. 200. So we know speed is 200 meter per second. Got it? And 1 minute. What nonsense. This is 100 centimeter, right? So we will say lambda into frequency is speed. So what is frequency? Speed upon lambda. So it is 200 meters upon 100 centimeter means 1 meter. So answer will be 200 hertz. Did you get it? 23. Length of the sonometer wire. Now what they are saying is this is the sonometer wire. So it should be kept like this. Okay. So the bridges should be kept like this. Let's say this length is L1, this length is L2 and this length is L3. Now what they need is that these three segments, the fundamental frequencies, okay. So F1 will be V upon 2L1, F2 will be equals to V upon 2L2 and F3 will be equals to V upon 2L3, right? Anyways, frequency is inversely proportional to length because the fundamental frequencies are this and the speed will remain same as the medium is same, right? So we will say F1 is to F2 is to F3 will be equals to 1 by L1 is to 1 by L2 is to 1 by L3. Now what is F1 is to F1 is to 2 is to 6. If we divide whole of this equation by 6, it will become 1 by 6 is to 1 by 3 is to 1 upon 1. So on comparison, we can say L1 is to L2 is to L3 is 6 is to 3 is to 1. So what is L1? It is 6 by 10 into 100. That is 60 centimeter. And what is L2? 3 by 10 into 100. That is 30 centimeter. But they want the distance from this point. So they are asking for L1 and L1 plus L2. So our answer will be 60 centimeter and 60 plus 30, that is 90 centimeter. So answer will be 60 and 90, right? Because they are looking for this distance and this distance. Clear? So it is 60 centimeter and 90 centimeter. Got it? So when the tension in a string at fixed at both ends, okay, so string is fixed at both ends, tension, okay, okay, see, frequency is equal to n by 2l into root over t by mu. Frequency increases by 10 hertz, okay, so frequency increases by 10 hertz if it is 1.44 t by mu. So if you take the ratio, you will say f upon f plus 10 is 1 upon 1.2, right? So 0.2 f is equals to 10. So f is equals to 50 hertz. Got it? A sonometer wire is vibrating in the second overtone. See, second overtone means n is equals to 3. N is equals to 1 is 0th overtone. N equals to 2 is first overtone. So n equals to 3 is second overtone, right? And that means that it is operating in the second overtone means third harmonic here. So like this will be the shape. Antinodes 1, 2, 3 and nodes will be 1, 2, 3 and 4. So 4 nodes and 3 antinodes. 26. What they are saying is a tuning fork is used to produce resonance in a glass tube. Okay, this is our glass tube. So when the water level is this, some resonance was obtained. When the water level was dropped down to some other point, then again resonance was obtained. It must be in this condition, yes or no? Now this height is 20 centimeter given and this height is 73 centimeter given, right? So we can say that this distance is lambda by 2. So lambda by 2 is equals to 73 minus 20, that is 53 centimeter. So from here lambda will be 106 centimeter. So Frequency is given 320 hertz. So what is velocity? Wavelength into frequency. So 1.06 into 320. Remember to convert it into meter also. Got it? Now velocity will come out to be 339 meter per second. Clear? 27. A string is stretched between 2 points separated by 75 centimeter. Okay. It is observed to have resonant frequencies 420 Hz and 315 Hz. Let's say when it is fixed at both ends, so one is NV by 2L is 315 and N plus 1, the later one, is 420. So what is the difference? If this is equation 1 and this is equation 2, and if you do this equation 2 minus equation 1, then it will be 420 minus 315, which is V by 2L, which is actually nothing but fundamental frequency, that is 105 hertz. See what happens, you remember this thing, when both ends are closed, then the coming frequencies are nothing but the integral multiple of the fundamental frequencies. See, so f is nothing but nf naught, right? Nf naught. So the difference between two consecutive frequencies is nothing but fundamental frequency only. So the difference of 420 and 315 is nothing but the fundamental frequency only. Now, a closed vessel A having volume V contains nitrogen at pressure P and temperature T. So, what is molecular mass here? 28. Now, another closed vessel having same volume contains helium at the same pressure, but temperature is 2T and molecular mass is 4. Okay, simple. See, PV equals to MRT by M naught. So here everything is given. So if you say that M1 T1 by M naught 1 is equals to M2 T2 by M naught 2. Do you understand? Because P, V and R, all these three are constants in both the cases. So M1 upon M2 will nothing be T2 by T1 into M0 upon M0 1 upon molecular mass of the second case, right? So T2 is what? 2T, right? Now what is the first molecular mass? How much is this? 28. This is what? 4. 2 ones are 2 twos are 2 ones are 2 14s are. So answer will be 14 is to 1. Fourth option is correct. Got it? 29. PV equals to nRT. So delta V by delta T is nR by P. So slope is inversely proportional to pressure. So increasing slope reduces pressure. So P2 is less than P1, right? First option is correct. At constant pressure, V1 and V2 are the volumes of given mass of a gas. Okay, PV equals to nRT. So if P is constant, V is equals to nR by P into T. So V is directly proportional to T, right? So V1 by V2 will be T1 by T2. What is T1? 300. What is T2? That is 273 plus 54. Right? Clear? Now you solve it, you'll get the answer. That is what? It is 327, right? 300 upon 327. So it is 100 upon 109. Got it? Now 31. The initial temperature of a gas is 200 Kelvin. and the pressure, okay, closed vessel. It is given that it is a closed rigid vessel. So volume is constant. So PV equals to nRT. If volume is constant, you will say P is directly proportional to T. So for small changes, we can say delta P by P is equals to delta T by T. So delta P by P is actually 5 by 100 because it is 5 percentage. So delta T by T is how much? 200 Kelvin. So what is the answer? Delta T is 10 degree centigrade. Okay. Now, in order to increase the volume of a gas to three times at constant pressure, okay, simple. See, PV equals to nRT once again. Pressure is constant, volume is directly proportional to temperature. So you are saying V1 by V2 is T1 by T2. Now volume of the gas is three times. So V1 is equals to V, V2 equals to 3V. So you will say V upon 3V is equals to T1 upon T2. So T2 is nothing but 3T1. Now what is T1? 273 plus 40 Kelvin. So final answer will be 3 into 273 plus 40 is how much? 273 plus 40 is 313. Right? 313. Okay. Minus 273. Answer will be in degree centigrade. Clear? So your answer will be 666. Now, if both temperature and volume of an ideal gas are doubled, the pressure will obviously remain unchanged. See, volume is doubled, temperature is doubled, doesn't matter. Why the hell pressure should change? Because this factor will get cancelled. Okay. See, PV equals to nRT. PV equals to M by M naught RT. P is equals to, P equals to M by V into RT by M naught. M by V is what? D. So pressure is equals to density into R into T by molecular mass. So we say that P by, so delta P by delta D, that means change in pressure upon change in density is RT by M naught. This is the slope. So from here we can say that slope is directly proportional to temperature. So greater slope, greater temperature. So T1 is greater than T2 because slope of first line is greater. Got it? 35. 1 liter of helium gas at pressure 76 centimeter of mercury and temperature 27 degrees centigrade is heated till its pressure and volume are doubled. The final temperature will be C. Pressure volume equals to nRT. So pressure is doubled, volume is doubled. So nR T2. So obviously T2 is 4 times T1. So T2 is 4 into not 27 degrees centigrade 3. So it is 1200 Kelvin. So in degree centigrade it will be 1200 minus 273 degrees centigrade, which will be 927 degrees centigrade. Got it? Now they have given current I is equals to 2T plus 3T square. So it is what? dq by dt is equals to 2T plus 3T square, and what they need is charge flowing. So dq will be integration of 2T plus 3T square dt from t equals to 2 seconds to t equals to 3 seconds. Okay, do this integration, you will get your answer as 24 coulombs. Now here what they are saying, electrolyte, saying that bivalent positive ions, that means A2 plus ions, are moving to the right and B negative ion is moving towards left. Okay, so overall current will be in the right. So we will say movement of negative charge in this direction is equivalent to, this is equivalent to, See, electron going in left means a proton going in right. Okay, so it will become A2 plus equivalent to B plus. So overall current will be in this direction. That means 3 positive charge are going in this direction. So let's say A2 plus, how many are they? 3.2 into 10 to the power 18 into 2 plus 3.6 into 10 to the power 18 in the same direction because they are going, multiplied by charge of a single electron will give you the total current. Got it? So 6.4 plus 3.6 is 10 into 10 to the power 18 into 1.6 into 10 to the power minus 19. So it is 1.6 amperes towards right. Got it? 38. What they are saying is this is 100 ohms. So let's find R equivalency. This is 100 and this is 50. 150, 150 in parallel will become 100 by 3. Remember this trick I will tell you. Whenever you have R and 2R in parallel, R equivalent is 2R by 3. Okay, got it? So here this is R and this is 2R. So answer is 2R by 3, that is 100 by 3. And this is 26 volts. Now, what is the, see, what is the current? I will be what? I into 10 plus 100 by 3 is equals to 26. So it is 130 by 3 is equals to 26. So I will be how much? 0.6 ampere. Okay, I will be how much? 0.6 ampere. Now, what is the potential drop in this? In this potential drop will be I into R. That is 0.6 into 10. That is 10 volts. So if potential drop here is 10 volts, so here it will be 26 minus 10. That is 16 volts. Sorry, what I'm doing? 0.6 into 10 is 6 volts. So here if the drop is 6 volts, so here the drop will be 26 minus 6, that is 20 volts. And same will be the potential drop in voltmeter also. It will read 20 volts. Understood? Now, heat generated is V square by R, directly proportional to. So if you cut the coil, so obviously it will become R by 2. So heat will be doubled. Got it? 40. Two wires made of the same material have their lengths in the ratio. So L1 is to L2 is 1 is to 2, and their masses M1 is to M2 is in the ratio 3 is to 16. See, mass is density into volume, right? So M1 by M2 is V1 upon V2. Right. So we will say resistance is rho L by A, or we can also say it is rho L into L upon A into L. So it is rho upon V into L square. Right. Now we can say that R1 by R2 will be L1 by L2 whole square into V2 by V1 whole square, which will be L1 by L2 whole square into M2 upon M1, not square. Got it? So it is 1 is to 4 into 16 is to 3. So answer will be 4 is to 3. Got it? Now here it's very easy. Length is mentioned L and 2L, and areas are also mentioned, right? So R1 upon R2 will be nothing but L1 by A1 into L2. Like this. Solve it and get your answer. Now one thing for sure, this is important. They are saying that R1 plus R2 is equals to R1 dash plus R2 dash always. So R1 plus R2 is equals to R1 into 1 plus alpha delta t, alpha 1 delta t, plus R2 into 1 plus alpha 2 delta t. So we can say that R1 plus R2 is equals to R1 plus R2 plus R1 alpha 1 plus R2 alpha 2 into delta t. Now obviously they will get cancelled and you will say, sir, R1 alpha 1 is equals to minus of R2 alpha 2. This is the case, right? So nothing you have to do, you just have to put the values and get the answer. Alpha 2 is already given negative minus 0.5. This is alpha 2, this is alpha 1. Put the values R1, R2. Acha, if you don't know, then R1 plus R2 is given 36. Right? So you will use this equation also and this equation. Okay? Then you will definitely get your right answer. Got it? Question number 43. What they are saying? A wire of length L and linear density M is stretched to force tension T and frequency is N1. Okay, another wire of same material of length 2L, same linear density is stretched to a force 90. See, frequency is equals to N by 2L into speed is root over T by mu. Right? So, F2 upon F1 will be equal to L1 upon L2 into root over T2 upon T1, right? So everything is given, put the values, get your answer. L1 by L2 is what? L upon 2L into T2 is how much? T2 is 90 upon T. So answer is 3:2. 44. The fundamental frequency of a closed organ pipe length is 20 centimeter is equal to the second overtone, okay, of a closed organ pipe L1, let's say L1, the fundamental frequency is equal to the second overtone. Second overtone means n equals to 1, n equals to 2, n equals to 3. This is zeroth overtone, this is first overtone, this is second overtone. Second overtone means like this, okay? So this is L2. So here n will be 3. So you will say that frequencies are same. So it is V upon 4L1 is equals to 3V upon, because it is third harmonic, right? Third harmonic, third multiple upon 2L2. So from here you will say L1 by L2 is equals to 1:6. So L2 will be 6L1. So L2 will be 120 centimeter. 45. The two nearest harmonics of a tube closed at one end and open at other. See, we will say that generally what is the frequency? 2n minus 1 V upon 4L. Next higher frequency will be what? 2 into n plus 1 minus 1 V by 4L. So it will become 2n plus 1 into V by 4L. Now if you do FB minus FA, it will be V by 2L, which is 40 Hertz. But what is the fundamental frequency? In this case V by 4L. So it is 40 by 2 Hertz, that is 20 Hertz. Do you understand? See, V by 2L is 40. So what is V by L? 80. So V by 4L is 20, or we can say V by 2L is 40, so V by 4L will be 40 by 2, 20 hertz, right? A wire of length L having tension T, radius R vibrates with natural frequency F. Another wire of the same metal, so see, frequency is NV by 2L. It is N by 2L into V is root over T by density into area is pi R square. So frequency is N by 2L into R into root over T by rho into pi. So frequency is directly proportional to root T upon length into radius. Okay. So whatever changes they have done, do it accordingly. You will get your answer. So you will say F1 by F2 will be equals to root over T1 by T2 into L2 by L1 into R2 by R1. Got it? Now whatever ratio they have given you, put it there and get your answer. Done? Okay. 47. A pipe open at both ends oscillates in a frequency F1. When the pipe is kept filled up to 3/4 of its length, only L by 4 is available. So first complete L was available and it was open pipe. Now the frequency is F2C. When it is open, perfect. So we will say F1 is equals to V by 2L and F2 is equals to V upon 4 into what is length? L by 4. So F1 by F2 is equals to V by 2L upon V by L, that is 1:2. Clear? See here fundamental will be like this. This is the case of fundamental and here the fundamental will be like this. Right? Now a stone hangs from the free end of a sonometer wire. See, this is the situation. This is the stone. So initially when it was not dipped anywhere, so tension was T1, right? So what they are saying is same tuning fork. Okay. See, frequency is constant because same tuning fork they are using. They are using what? Tuned to a tuning fork is 40 cm. So initially the length is, see, V upon 2L1. What is V? So 1 by 2L1 into root over tension T1 upon mu. And again the same frequency but the length has changed to L2. Same but T2 upon mu. So answer is like this. See, root over T1 by T2 is equals to L1 by L2. So T1 upon T2 is equals to L1 by L2 whole square, that is 16 upon 9. Got it? No problem. Now what is T1? See, T1 is equals to mg. What is T2? When it is dipped in water, so there is a buoyancy force upwards and mg downwards. So this time T2 is mg minus buoyancy force also, right? So what we will do, we will say that T1 by T2 is mg upon mg minus buoyancy force. It is 16 upon 9. After solving this, since I don't have enough space, I will write here. After solving this, you will get that mg upon fb. Okay, this comes out to be 16 by 7. Okay, this comes out to be 16 upon 7. Clear? Now if this is 16 by 7, so mg is what? Volume into density of object into g. Buoyancy force is what? Volume into density of liquid into g. Right? So volume gg gets cancelled. So you are saying that density of object upon density of liquid, which is relative density, it is 16 by 7, or specific gravity also. Clear? Now what they are saying is a cylindrical tube of uniform cross section is fitted with two airtight frictionless pistons. Okay. See, let's talk about the equilibrium position of any one of the piston. This is tension T. This is the external pressure P naught A. This is the internal pressure PA. So you will say P naught A plus T is equals to PA. So T is equals to P minus P naught into A. Now what they have done is volume is constant, right? Volume, PV equals to nRT. If volume is constant, so P is directly proportional to temperature. So if temperature becomes 2 T naught, P also becomes 2 P naught. So tension will be 2 P naught. Let's say tension to be F, otherwise it will confuse with temperature, right? This is force F of the rope, which is tension of the rope, minus P naught into A. So it will be P naught into A. See, both the sides force will be applied from inside the cylinder and outside the cylinder, right? Outside the cylinder, the atmospheric air is applying force or pressure, and from inside the inner gas is inside gas, the internal gas is applying the pressure or force. Now here it's very simple. 1 mole of a monatomic gas is brought from state A to B. Initial temperature is T naught. The temperature of B at B will be okay. See, PV equals to nRT. We can clearly see that P is directly proportional to V, right? Or I can say that P by V is a constant, right? So we can say that P by V is a constant. So PV equals to nRT. We will say that P is directly proportional to V, or P is constant to V. So V square is directly proportional to temperature, right? Do you understand? So our temperature is directly proportional to V square. So T2 by T1 will be V2 by V1 whole square. So if volume is 3V naught upon V naught whole square, temperature will be T2 upon T naught. So T2 will be 9 T naught. Got it? So this is how you will get your fourth option. That's all for today. I hope you have understood every solution that I have explained you, and I hope that this explanation helps you a lot in understanding the concepts of these particular chapters. Okay, so good luck for other exams, and keep on revising, keep on doing these papers again and again. Okay, so that it will help you build a strong conceptual base. Thank you so much, students. That's all for today. Tata, bye bye, and subscribe to our channel.